This is the fall 2014 AP Calculus prep session. This is part 4, which is a free response, a non-calculated free response problem that deals with the relationship between f prime, and f double prime. And this one is, let h be a function defined for all h not equal 0 such that h of 4 equals -3, and the derivative of h is given by h prime of x equals x squared minus 2 over x for all x not equal to 0. And so we're dealing with an h prime, and we're trying to find first of all, find all values of x for which the graph of h has a horizontal tangent, and determine whether h has a local maximum, local minimum, or neither at each of these values. Justify your answers. Well, to find our critical numbers, we're going to find where the values of x that make h prime of x either equal to 0 or undefined. And we know that since our denominator, we have x, we know that x equals 0. X cannot equal 0, so x equals 0. This is a critical number. I'll put critical number. And also we can set the numerator equal to 0, so x squared minus 2. And factoring, what we have is 0 equals x, the square root of x squared is x. We're going to have plus or minus the square root of this value here. So we're going to have x plus square root of 2 times x minus square root of 2. And solving for x, if we set each of these factors equal to 0, we're going to have x equals negative square root of 2 and x equals square root of 2. And to do our analysis, we go ahead and put these numbers on a number line. That's a little more horizontal looking. Okay, where our critical numbers are going to be negative square root of 2, and our 0 where the function is undefined, and we have square root of 2. So we'll say undefined here at x equals 0, and above here we're going to put h of x, h prime, excuse me, and h below. And to the left of negative square root of 2, we're trying to find local minimums, maximums, and neither anyway. At the left of negative 2, what's a number that's less than negative 2? Well, how about negative square root of 2? How about negative 2? So if we have negative 2 squared, which is going to be 4 minus 2, that's going to be positive. So we have the function increasing up to negative 2. And between negative 2 and 0, how about negative 1? If we put in negative 1 squared, that's going to be 1 minus 2, that's going to be negative. So we're going to be going down here. Now if we go to the right, between 0 and 2, we're going to have, let's see, negative 1, that's going to be 1 minus 2, which will again be negative. And then if we go to the right and pick a number bigger than square root of 2, which is 2, we'll have 2 squared, which is 4 minus 2 is positive. So, horizontal tangent, looks like we have horizontal tangent at x equals negative square root of 2 and square root of 2. So we're going to say, and it says justify, I'm going to put negative square root of 2 and square root of 2, why? Let's see, because h prime changes from plus to negative or negative to positive. Anyway, that's kind of condensed way, right? On what intervals, if any, is the graph of h concave up? Justify your answer. Well, again, we're given a h prime. To get concavity, we have to find the rate of change of the rate of change. So we're going to find the rate of change of the rate of change by taking this h prime of x, and we're going to rewrite this so we can differentiate easier. We're going to have x squared over x minus 2 over x, which equals x minus 2x to the negative 1 power. And so the next derivative of that is going to be h double prime of x is equal to 1, and we're going to take this negative 1 times negative 2, so we're going to get plus 2x to the negative 2 power, which equals 1 plus 2 over x squared. And we can set this, you can find on what intervals is the graph concave up? Well, this is, no matter what numbers we put in, this is always going to be positive. H double prime x is always positive. On what intervals, if any, is the graph of h concave up? Well, on negative infinity to infinity for x not equal to 0. So because h double prime of x is always positive, is always greater than 0. All right, write an equation for the line tangent to the graph of h at x equals 4. Well, we need to write a tangent line. We need a couple things, don't we? We need a point, and right at the beginning of the problem, we are given that point. We have h of 4 equals negative 3, so our point is going to be 4, comma negative 3, and then what we need to find is the slope. So slope, which equals, call it m sub t. Well, to find our slope, we can plug 4 into h prime of x here. So we're going to say h prime of 4 is equal to 4 squared minus 2 over x, which is 4, which equals 4 squared minus 2, that's 16 minus 2, that's going to be 14 over 4, which equals 7 halves, 7 over 2. So now we can write that tangent line, and to do that, our tangent line is going to be y minus y sub 1, which is going to be plus 3 minus negative 3 plus 3 equals 7 over 2 x minus 4. So that's going to be our answer to part C. D, does the tangent line of graph h x equals 4 lie above or below the graph of h for x is greater than 4? Why? Well, the answer to D is below the graph. Why? It's simply because h of x is concave up. So what that's going to look like, you have a concave up graph here. So any place, let's say here at x equals 4, right? Any place on this whole graph where the function exists, your tangent line is going to lie below the graph. So anyway, that's this whole problem worked out. One thing when I looked at the grading scale for this, one thing you have to do in some way is address that x cannot equal 0 to handle this undefined part, which I think if this in part B, where we mentioned for x is not equal to 0, I think that's going to probably satisfy them. They're not supposed to look at a number line, but if they do look at a number line, that would help get that right too and avoid getting that point taken off for not dealing with that discontinuity. Anyway, that's the end of part 4. Thanks for viewing.